Hello my dear students, this is Akash SD. Welcome to the ASD physics classes students. I hope so you all are doing really great. So students, in this video we are going to solve the questions based upon questions that can be solved by uniform acceleration, and some of the questions can be identified and they are belongs to the non-uniform acceleration, and for that we have to use the concept of differentiation and integration. Okay, so all these things we are going to do. So before solving the question, we are going to understand some basics so that it will be helpful to solve the questions. Okay, so remember that here first thing, whatever equations of motion you know, that is applicable when A is constant. What I am telling? When A is constant, that means uniform acceleration, that time only we can use the equations of motion. And what are the equations of motions are there? Like V equal to U plus AT. U is initial velocity, V is final velocity, A is acceleration, and T is a time. Similarly, we can write a displacement S equal to ut plus half at square. Okay, S is the displacement. Even we can use one more formula that can be used, u plus v by 2 into t, depending upon the requirement. Next one we can use here, v square equal to u square plus 2as, is it? And one more formula is there, displacement in nth second. So Sn equal to u plus half a2n minus 1, is it? So all these formulas will be applicable when uniform acceleration is there. After that, remember that here second thing, if in case A is variable or we can tell non-uniform acceleration. So in this situation, equations of motion will not work out. So remember that here we can use it A equal to dv by dt, or we can tell V into dv by ds, okay, or we can use the formula V equal to dx by dt. This differentiation and integration formula that can be get by using this, that we have to use it. And next one, remember that here the third basics, in which situation velocity will increase and in which situation velocity will decrease. So remember that here, when velocity and acceleration both in same direction, or we can tell like this here. Okay, so you can see in first diagram, velocity and acceleration right side, and in this direction velocity and acceleration left side. So what will happen that here in these situations, what will happen all the time? So velocity will increase. Before also I have covered, but I am telling you, V positive, A positive, I am using the mathematical condition. So here V will increase. Similarly, if we talk about here this one here what we can tell here, velocity is negative and we can tell acceleration is also negative from the direction. So here what will happen that here velocity will decrease. Okay, similarly if we talk about here the next one, let's take here, let's take velocity in this direction, acceleration opposite direction. So here V positive, A negative, velocity will decrease here. Okay, and if I take one more here, let's take here for example, velocity in this direction, acceleration in this direction. So here what will happen that here velocity is negative and acceleration is positive. So here also what will happen, this velocity will decrease here, is it? So students, all these basics should be remembered to solve the questions, is it? So let's start the question solving. So here you can see the question is asked in a JEE 2023. Let's go through it. A particle starts with an initial velocity of 10 meters per second along x direction and accelerates uniformly at the rate of 2 meters per second square. The time taken by the particle to reach the velocity of 60 meters per second. Nothing is mentioned. One time they have told x direction, that means we will consider object is only moving along x direction. Okay, so we'll note down here the values. So initial velocity along x direction, it is given here how much here, 10 meters per second. Now you can see very well 10 meters per second. After that accelerates uniformly. Now that means anyhow the velocity will increase. How much is given here, 2 meters per second square along x direction. That's why we are using the suffix x. Now similarly final velocity how much here, just see the question and think how much here, 60 meters per second here, 60 meters per second. And what they are asking here the time taken. Okay, even here also if you wish you can use here the suffix, but for time no need to use the suffix, that you will understand in a motion in a plane. Okay, so remember that here as we know V equal to U plus AT, in which direction, x direction. Okay, so from here this T is given by Vx minus Ux by Ax. Okay, we'll put the value here. Vx means 60 minus Ux how much here, 10, and ax value how much here? 2. Everything we put in SI. Okay, so 60 minus 10 means 50 by 2, and how much it will come here? It will come here at 25 seconds. That means it will take how much time? 25 seconds. And velocity is increasing, so correct option is here. Option C is the answer. U is positive, V is also positive. That means anyhow the velocity is increasing. See here, this. See, this is positive and this also positive. Both are positive. Anyhow, velocity have to increase only. Okay. See. Next question, let's see. JEE 2024 question applicable for the NEET also. See here. A body starts moving from rest. The moment they told from rest means U is 0. Okay. With constant acceleration, that means equations of motion will be valid. Okay. Covers displacement S1 in first P minus 1 seconds and S2 in first P seconds. Okay. Now, the displacement S1 plus S2 will be made in how much time? Okay. So here remember that here we will use the formula, second equation of motion, S equal to ut plus half at square. As it is starting from the rest, U will be 0. That means we can use here, this is the formula, S equal to U is 0. So we can use here S equal to half at square. When the object starts from rest, U will be 0. This formula we can use here. Okay. Now we will use in our question. So what they are telling that here, S1 displacement when, how much time? P minus 1 second. So we can write here, see, S1 equal to half, and here we can write here first P minus 1 second. So half A P minus 1 square. No, P minus 1 second. S2 for P seconds here. So we can write here, see, S2 what is given here? Half acceleration is A, and how much times is there? P seconds are there. So P square is there. Okay, and let's take for S1 plus S2, it takes T seconds. No? So remember that here we are going to use here S1 plus S2. S1 plus S2 will become what here? See here, half A. Take here half A common, so it will become here what? P minus 1 square, is it? Plus P square. And for S1 plus S2, how much time it is taking? T seconds. And anyhow starting from the rest only. Okay. That means we can write here, see, half A T square is equal to half A. Simplify this. P minus 1 square means P square plus 1 minus 2P, formula of A square plus B square minus 2AB. That is the formula of A minus B whole square. Okay. And this is the plus P square here. Okay. P minus 1 square, we have written this. Is it? So what will happen that here? Both the sides, half A and half A, cancel. So we can write here T square is equal to P square plus P square, 2P square, and minus 2P plus 1. Is it? When you will remove the square root, no, this square you will send that side. So it will become here what is here, students? 2P square minus 2P plus 1. Is it? Kindly check it out. Any options are matching? Square root only in one option is there. The correct option is here. Option B is the answer here. Okay. Now let's move to the next one. Now the question is, see here, the question is the distance traveled by a particle, again starting from the rest, U equal to 0, moving with an acceleration of 4 by 3 meter per second square in the third second. What is given here? The key word is the third second. Third second. That means here we have to use the displacement in nth second formula. Okay. So here students here. See. So starting from the rest means anyhow U is 0. Next one, acceleration it is given here. 4 by 3 meter per second square, we can see very well. And they are asking in which second? Third second. That means the value of n is 3. Okay. After that, see, as formula, as I have told you, displacement in nth second, U plus half A 2n minus 1. And I hope so you know very well, when the object is traveling in a straight line without changing direction, then distance and displacement both will be same. Okay. So here what will happen that here? 0 plus half. A value how much is given here? You can see very well, 4 by 3. Okay. And here 2 into n value is third second. So 3. 3 minus 1. So we can write here, see, half into 4 by 3 into 2 into 3, 6 minus 1, that means 5. Okay. So simplify this here. We can write here 2 2 is 4. So 2 into 5, 10 by 3 meter. Okay. So in third second, 10 by 3 meter. The correct option is here, option D. Okay. Very formula based questions are there. No? Next one, let's move here. See, very basic question. See, a particle starts moving with acceleration 2 meter per second square. Distance traveled by it in fifth half second. What they are telling? Fifth half second. Okay. So remember that it starts moving. That means U equal to 0 anyhow meter per second. Okay. acceleration, how much is given here? Can you see here, students? It is given here a equal to 2 meter per second square. And the next thing they are telling that here, fifth half second. Okay, so here you have to decode it. What is the meaning of the fifth half second? Fifth half second. Fifth half second means, see, fifth half. So first you will do 5 by 2. 5 by 2, how much here? 2.5. That means, again I'm telling that here, fifth half means 5 by 2. See here, 5 by 2 I will do here. It will come here 2.5. See, I'm writing here. Fifth half means 5 by 2. How much is coming here? 2.5. That means fifth half second means from t equal to 2 to t equal to 2.5 second. Is it? Remember that here. Okay. Now after that here, t equal to 2 to t equal to 2.5, and object is starting from the rest. That means again anyhow we can use here s equal to half a t square. That means if we have to calculate here how much it will travel, so I can write here, let's take here S1 is given by displacement. They are telling displacement, no? Okay, distance. Traveling in a same direction, means traveling in a straight line without changing direction. So we can tell distance in a 2.5 seconds minus distance in 2 seconds. Okay, so I can write here, see, half a 2.5 square minus half a 2 square. Okay, so anyhow we can write here half a common. 2.5 square means 2.5, 25 into 25, remember that here, it will become here 6.25 minus it will become here 4. Okay, and what is the value of the a? With the value of a is 2. So we can write here, see, half into 2, 6.25 minus 4, 2.25. 2 and 2 cancel. That means in fifth half second, it is going to travel 2.25 meter. Okay, I hope so. Calculations are the very correct. Is it? Okay, great. Now, but one thing, fifth half second means 5 by 2, 2.5. Okay, but anyhow, I will tell you some basics. If in case they told here, let's take for example, seventh half second. What they told is seventh half second. So what you will do here? Seventh half means 7 by 2 means 3.5. That means meaning here t equal to 2 to t equal to 3.5 second. Now this thing should be known. If in case they told a ninth half second, then guess and tell me. Ninth half second means where to where? 9 by 2. 9 by 2, 4.5. That means here t equal to 4 to t equal to 4.5 second. Now you can write second also. Okay, and if we go here like this, even numbers, let's take the told here sixth half second. What they told here, sixth half second. So sixth half second means you will do 6 by 2, 3. 6 by 2, 3. That means t equal to 2.5 second to t equal to 3 second. Like that difference will come. One more example for you. I have taken eighth half second. Eighth half second. Okay. 8 by 2. 8 by 2 means 4. That means we can write t equal to 3.5 second to t equal to 4 second. Okay. So here when you will do 7 by 2, 3.5. Like it will come here. 9 by 2, 4.5. But when here you are doing 6 by 2 means 3. Is it? So what this will come here? It will come here. Is it? So I hope so. This basic is the very clear to you. Okay, students, kindly remember it here. Okay, now let's move to the next one. Now here the question is, let's go through it. JEE 2024 question is there now. Let's see here. The displacement and the increase in the velocity of a moving particle in the time interval t to t plus 1 second are 125 meter and 50 meter per second respectively. The distance traveled by the particle, okay, the distance traveled by the particle in t plus 2 seconds is how much here? Okay, so first we have to note down here the data and all here. Okay, so they are telling that here time how much is given here. Remember that here, see, t to t plus 1. T to t plus 1 means how much time? 1 second. Now final time minus initial time. So how much time? 1 second here. Okay, and remember here they have given here the displacement as they have given here 125 meter, and the velocity, okay, displacement and the increase in velocity. Again I'm telling that here, increase in velocity, delta v is given here 50 meter per second here, or you can write here even v minus u also, final minus initial. Okay, So here, as it is a matter of 1 second, so remember that here I will use the formula Sn equal to u plus half a 2n minus 1. Okay, this formula I am going to use here. Now, so first one we are going to use for t to t plus 1 second. Now, t to t plus 1, that means how much here? 1 second. Now, 1 second. Time interval how much here? 1 second. So, if I will use here, see here students, it is given here, displacement how much is given here? 125. So, we can write here, see, 125 is equal to, see this formula I am using is, now 125 is equal to u plus half a and 2n minus 1 here. For which time here? 1 second. This 1 second is the n. Okay. So 2 into 1 minus 1, no? Because n you put 1, so 2 into 1 minus 1, it will become here 1. Okay, 1. This is equation 1 we have got here because u and a is the two unknowns. Now again. If I use here this one here, v equal to u plus 80. Okay. So I can write here, see, v minus u equal to 80. Change in velocity, how much is given here? Kindly see here, 50. So 50 is equal to a into time. How much here? See, here as a n, this one, n, but here as a t, because anyhow time interval 1 second. Okay. So what will come here, students here? This a will come here 50 meter per second square. What is coming? A is coming 50 meter per second square. If this value I will put here, see, you put a 50 here. Now, so when I will put here a50, what will become here? See, 125 is equal to u plus a is 50 by 2 means 25. So hence u will come what here? 125 minus 25. That means it will come here 100 meter per second. Is it? So you can see very well, a value we have got 50, u value you have got 100 meter per second. Okay, but now the distance traveled by the particle in how much here? T plus 2 seconds. Starting from the t. So t to t plus 2, how many seconds? 2 seconds here. Okay. So remember that here, if we'll go for this one here, see here, I'll write here, see here, this student, see, t to t plus 2, I'll write here. Now, so see, t to t plus 2, this one is there here. Okay. So what will happen that here, remember that here, as we can write here, s equal to u plus half a 2n minus 1, is it? And we are going to use for the 2 seconds, for 2 seconds, okay, for 2 seconds. So what this will become here, if we are using for the 2 seconds, now displacement in 2 seconds, so remember that s equal to u, how much here? 100 plus half, and here you can tell here, a is 50, and here 2 into 2 minus 1, is it? Correct only? That means it will become, yes, here, 100 plus 50 by 2, 25, and here 4 minus 1, 3. So remember that here, 25 into 3, 75. 100 plus 75, 175 meter. What is coming here? Students, it is coming here in t to t plus 2. How much is coming here? 175 meter. Any option? 175. It is a NET kind of question. So we'll fill here 175. Okay, 175. Is it? NET kind of questions are there here. Okay, great. Now let's move to this question. No, this question. The question is what's here? The initial velocity of a particle moving along x-axis is u at t equal to 0 and x equal to 0. Now, and its acceleration a is given by a equal to kx. Which of the following equation is correct between its velocity u and position x? Okay. So here what will happen that here, students, first you identify here acceleration is uniform or non-uniform. Okay. So remember that here a equal to kx. Variable, when x will change, a will also change now. So that means this is a non-uniform. What is this here, students? This is the non-uniform. So when you are non-uniform and the equation is looking like a third equation of motion, so what we'll do here, we will use here some differential equations. Okay, and you know which equation I'm going to use here to prove this third equation. I'm going to use this one here. Now, even in my previous video also I have covered it. A equal to v into dv by dx. Okay, so I can write here v into dv is a into dx. I will put here the integration. Okay, so this is the basic equation. I will use it here. Now this is the equation. Now after that here, see, I will put here the limits. Limits, let's put here, see here again, v into dv, and here integration of value of a, how much? You can see a is how much given here? Kx. Okay, so kx into dx. Kindly put the limit here, students. So see here when x equal to 0, see here when x equal to 0, okay, time is there, but here we need the velocity. Initial velocity, anyhow, when you will check the options, initial velocity should be u only. Okay, that means we can write an initial velocity. Now this indicates velocity, this indicates position. Okay, so when position is 0, velocity is u. After that, if the position is x, let's take here final velocity is v. Okay, so after that here let's use here v into dv means here v square by 2. Put here kindly u2v is equal to k, anyhow constant that will come outside, integration of x dx. Kindly see here, it will become here x square by 2 and it will become here 0 to x. Is it? Then we have to just put here the limits. Okay, and anyhow even you can cancel this 2 and 2 also, no problem here. Okay, so when we will go ahead, remember that here see this will become here see v square and here limits what? u2v, and here it is coming here kx square and here limits where to where? 0 to x. No, mistake should not happen below. So let's see here, no, because 2 to anyhow both the sides cancel. No, so it will become here upper limit means v square minus u square is equal to k x square minus 0 square. So when you will simplify this, it will come here v square is equal to u square plus kx square. Okay, v square equal to u square plus kx square. Is it? So let's see which kind of options are available here. Anywhere v square equal to u square plus kx square, the correct option is here, option C is the answer here. Okay, but here I will tell you one mistake is there that you should not commit. The common mistake is this, the common C-O-M-M-O-N, common mistake. C-O-M-M-O-N, common mistake. Number of times what students they do, they will write the equation v square equal to u square plus 2ax, and what they will do, v square equal to u square plus they will put the value of a like it is given kx into x, and then they will write here like this, v square equal to u square plus 2kx square. So can you see here? Can you see here? This is the correct answer? No, this is not the correct answer. Why? Because this equation of motion we can't use it, we cannot use it. Why? Because acceleration is non-uniform. Okay, so this answer is wrong. Remember that here, this answer is wrong. The moment acceleration is non-uniform, equations of motion you cannot use it, not applicable. Okay, great. Now let's move to the next question. The question is what's here? The acceleration of a particle is increasing linearly with the time t as bt. Okay, now see, the particle starts from origin with an initial velocity v0. It starts from origin means anyhow it is given x is 0. Okay, the distance traveled by the particle in time t will be how much here? Okay, so now here they are talking in terms of time. Now, so see here this acceleration is given here bt and this is non-uniform. Equations of motion will be invalid. Okay, so now what we have to do here, these equations are looking like a second equation of motion. Is it? So whenever we are going to derive the second equation of motion, we need the velocity from the first equation of motion. If you know the basics, you know this. Okay, so first we should get the first equation of motion, then only we can go ahead here. Okay, so for the first equation of motion I will use a equal to dv by dt, that means dv equal to a dt. What is this is here? dv equal to a dt. This integration, this one we have to use it first because we need the velocity. Okay, then only we can go ahead. So here the students say this is dv is equal to, put the value of a. What is a? bt, b is constant, so t dt here. Okay, this integration. Now let's put the limits here. When the time t equal to 0, okay, and the initial velocity what is given here, v equal to u. When the time is t, final velocity is v. Again I am telling that this is indicates velocity, this is indicates time. Okay, so integration of the dv means v u to v equal to here anyhow b, and it will become here t dt means t square by 2 0 to t. Okay, so it will become here, see here, v minus u, upper limit minus lower limit is equal to b by 2, and it will become here t square minus 0 square. So what we have got here? We have got here v equal to u plus half bt square here. Remember that here, everything I will do it here. As of now I am considering this v naught as u. Later at the place of u, I will put v naught here. Okay, so I think so this first equation of motion is very, very clear to you. Now we have to go for the second equation of motion. Okay, and let's see here. See, as for the second equation of motion, we use v equal to dx by dt. That means dx equal to v dt. What is this? Dx equal to v dt integration. Okay, so see here now. Integration of dx means what is the value of the u that we have done now? U plus half bt square. Now I will just go. Otherwise mistakes should not happen here. Now see here, u plus half bt square here. Okay, and here it will become here the t dt. Okay, now we'll separate it here. Integration of dx is equal to, we can write here u integration of dt plus b by 2 integration of t square dt. Okay, we are just simplifying this here. Now let's take here t equal to 0, t equal to 0. Object starts from origin, that means x equal to 0. After that here, after time t, now let's take here position is s. So what this will become here? Integration of the dx means x 0 to s. Here u integration of the dt means t 0 to t. Is it correct? Plus b by 2 t square dt means what will become here? T cube by 3, again here 0 to t. Okay, because this v value we have to put, otherwise second equation of motion we can't use it. Okay, so this will become here, see, s minus 0 is equal to u upper limit minus lower limit plus 3 will come outside, b by 6 upper limit t cube minus 0 cube. Is it? So after that, when we will simplify this, what it will come here? Kindly see here, it will become here, see, s equal to, this will become here ut plus 1 by 6 bt cube. Now 1 by 6 bt cube. And as I have told you very well, according to the question, they have given initial velocity v naught. So I will write here s equal to v naught t plus 1 by 6 bt cube here. Okay, this is the thing. But I will tell you, don't do this mistake. Answer came okay. But some of the students, they will write like this, s equal to ut plus half at square. And they will think initial velocity v naught t plus half, value of a how much is given? Bt and t square, and they will reach to the answer v naught t plus 1 by 2 bt cube. Is it? This answer they will reach. But what is this? This answer is wrong. Wrong. Equation of motion is not valid. Okay, so the correct answer is v naught t plus 1 by 6 bt cube. Okay, so where is the anyone here? V naught t plus 1 by 6 bt cube. Okay, now very basic, very basic. This one we have done it. Now let's see here this question here, the students see a car moving, with speed v on a straight road can be stopped within distance d on applying brakes. Applying brakes means here anyhow velocity and acceleration both in which direction? Opposite direction. If v positive, acceleration have to be negative, that means retardation is happening. Okay, if same car is moving with speed 3v and brakes provides half retardation, then car will stop after traveling how much distance here? Okay, remember that here in this kind of situation, remember that here if in case the velocity is positive, anytime if the velocity is positive, acceleration have to be negative, then only the car can be stopped, as I have told you in the starting. Okay, so first let's note down the data here. Okay, so first initial velocity is given v, after that initial velocity v, then they are telling second situation 3v. Now data. After that here, let's take here initial retardation is a. Okay, then what will happen that here? Here retardation, what are you telling that here? Half, now half retardation. That means it will become here a by 2. If you wish here, you can put minus also, no problem here. Okay, but minus I will include later so that the minus confusion should not come. So you know that here s equal to mistake happened. Okay, see v square equal to u square plus 2as. Is it? When the car is going to stop, final velocity 0, u square plus 2. Now I will put here minus a. Now retardation is happening, minus a into s. So what s will come here? S will come here u square by 2a. What is s? U square by 2a. This u square by 2a is called stopping distance. Which distance? Stopping distance. Okay. Now we can write here, hence this s2 by s1 is equal to u2 by u1 whole square into what we can write here, a2 by a1. Is it? Because we can tell very well S is directly proportional to U square by A. Is it? 2 is constant. Now let's put the value. That's it. Solve here. So see S2, initial distance D. U2 how much is given? 3V. U1 how much here? V. So 3V by V cancel, it will become here 3 square. Into what is A2 by A1? Not A2 by 1. Inversely proportional. No, inversely proportional. See, S inversely proportional to A. So if here 2 by 1 means here 1 by 2. Okay. So A1 by A2 will come what here? When you will do here A1 by A2, it will come here 2. Okay, just put here. That means here this S2 will come here. 9 into 2, 18. That means 18. Okay. So correct option is what? The correct option is here. Option D is the answer. Okay. Option D is the answer. Next one, let's see here. The next question came in a JEE 2024 question is this. Let's see here. A bullet is fired into a fixed target, loses 1/3 of its velocity after traveling 4 centimeters. It penetrates further D into 10 to the power minus 3 meters before coming to rest. The value of a D is how much here? Okay, so I will just draw here one target. Now let's take here one target like this. I have drawn like this here. This is some target is there. Now, and after that here, what is given here? Let's take the students. See here, the bullet is this. Now it is going to enter with velocity U. Okay, and how much velocity it is leaving? Losing 1/3 is left. Now, so if the U is there, 1/3 means U by 3 is lost. How much left? 2U by 3. Okay, so here please here, I will write here like this here. It will left with how much here the students here? It will left with 2U by 3. Okay, and after traveling how much distance? This distance, if I talk about here, this distance, what they're telling that here? 4 centimeter. Remember that here, 4 into 10 to the power minus 2 meter. After that, what is happening that here? It penetrates further before coming to rest. So again, it is penetrating further, no? And here like this. And here what is happening that here? Its velocity is becoming 0. What is happening? Velocity is becoming 0. And how much distance it is traveling? It is given here D into 10 to the power minus 3 meter here. Okay. And just for the symbolic purpose, I will write here. This is the velocity. This is the velocity. This is the velocity. Okay, just for the symbolic purpose. Okay. Now, if I talk about here the points, let's take here, this is point A, this is point B, this is point C, is it? So now, first I am going to use equation of motion. For this kind of situation, we will always use V square equal to U square plus 2S. And remember that here, anyhow, velocity is this side, positive, and retardation will be this side, and it will be negative. Remember that by default. Okay. So what is happening that here? If I use from A to B, where to where I am using? A to B. So remember that here the final velocity is coming what here? 2U by 3 whole square is equal to initial U square plus 2 here minus A into S. Now S I will keep as it is, but later I will put here this S value, this one I will put here. Okay, later. Or you can write here for the Devina, you can write here even AB also, no problem for me. So what this will become here, students, here? 4 square by 9 is equal to U square minus 2A SAB. Okay, so we can write here, see, 2A into SAB is equal to U square minus 4 square by 9. So when you will take here the LCM, it will come here 5U square by 9, is it? So if I write here SAB, how much it will come here, see the students here? 5U square. 2A will go this side here, so 18A. SAB is coming how much here? 5U square by 18A. Correct? 5U square by 18A. Now I will use from B to C. Okay. Again, let's write here the equation. V square equal to U square plus 2AS. Okay. Now I am going to use here from B to C. B to C means final velocity how much here? 0 square. Is it? And what is given here? U. Here, initial velocity how much is given? 2U by 3, no? 2U by 3. I will write here, see. 2U by 3 square, anyhow, plus 2 minus A, and now it is going B to C. Okay. So now we can write here what is given here, see. 2ASBC is equal to, see here, 4U square by 9. That means what is SBC? SBC is coming here, see the students here, 4U square by 18A. Is it? 18A. Now we will just take here the ratio. Okay, so let me take here the ratio here. So hence if I write here SBC by SAB. Now so SBC, how much is this here, students here? 4U square by 18A into SAB was how much here? 5u square by 18a. What is this here? That means 5u square by 18 is here like this here. 5u square, 18a will go here. Now what other things will cancel out here, students? Here 18a cancel, this u square, this square is cancelled here. Okay, that means we can write here SBC is equal to 4 by 5 into SAB. And what was the SAB? As I have told you, 4 centimeter. That means we can write here 4 into 10 to the power minus 2 meter here. Okay, so it will become here 16 by 5 into 10 to the power minus 2 meter, correct? Or we can write here 3.2 into 10 to the power minus 2 meter. Simplify this further. So 32 into 10 power minus 3 meter. And this thing we have to compare with d into 10 power minus 3 meter. So what do you think here, students? What is the value of the d? This is the d. This is the 32 here. Okay, this is the basics. But when the question came that time, that year I think so option was not matching. So they have given here the bonus point as I have got it. But here I have taken some options so that it can correlate, and here the answer is a 32. Okay, 32. No? Great. This also we have done it. Now let's see, this question is this. The question is what? See, JEE 2024 question is this. No? Let's see here. No? See the question. Time is there. For a train engine moving with a speed of 20 meter per second, the driver must apply brakes at a distance of 500 meter before the station for the train to come to rest at the station. Okay, now after that here, see, if the brakes were applied at half of this distance, the train engine would cross the station with speed root x meter per second. What is the value of the x? And they are telling assuming same retardation here. Okay, so first thing we'll take here the green situation, that is the initial. So see what things are given here. Speed is given here, 20 meter per second, that means anyhow positive. Distance, how much it is going to travel here? Let's take here s. No? S is going to travel here 500 meter. Okay, before the to come to rest, no? And it is coming to rest here. V equal to 0 here. Okay, so anyhow coming to rest means here stopping distance concept is here. Okay, so you know that here, see again I will use with the basic, no? S equal to V square equal to U square plus 2AS, no? And V how much is given here? 0 square, and U square means here anyhow students here 20 square plus 2 minus A into S how much is given here? 500. Okay, so again we'll simplify this. 0 equal to 400 minus it will become here 1000A. What is this? 1000A, correct? Na? 500 into 2, 1000A. So when you will simplify this, A will come here 400 by 1000, correct? 400 by 1000, is it? So anyhow this 0 is cancelled. What is coming here? 4 by 10 meter per second square. That much retardation is there. Okay, and you can see same retardation, that means value of A will take same, but how much distance is given? Half of this distance. That means now we will use it instead of 500 we will use it 125. Okay, and again we will apply here. Okay, so again see here as V square equal to U square plus 2AS here. Okay, and U anyhow how much is given here? 20 meter, 20. So it will become here 20 square. No, and here anyhow plus 2 minus A into S. S how much here? 250. Okay, so see the students here 400 minus 2, value of A how much is given? Same retardation, so 4 by 10 here. Okay, 4 by 10, and here how much is given here? 250 here. Okay, so what is this? This 0 cancel, so we can actually see 400 minus 8 into 25 here. So 400 minus 200. So what is coming this here, students? This V square is coming here 200 here. Okay, so we can tell here V equal to root 200 meter per second. Na? And this thing we have to compare with the root x according to the question. So what you think? What is the value of the x? The value of x will come here 200. The value of x is how much here, students? The value of x is 200, is it? That means we can go for the here. The value of x how much here? 200 here. 200. No, not a 0. It is written here 200 here. Okay, great. Now let's see. This question is here, students. The question is the last question. See, an engine of a train moving with a uniform acceleration, equation of motion is valid, passes the signal post with velocity u and the last compartment with velocity v. The velocity with which middle point of the train passes the signal post here. Okay, so remember that here one train is this, the length of the train is L. Okay, it is traveling, no? Some signal post is there, no? Signal post is this. So remember that here, let's take this is the engine here, engine is here, compartment is here. Okay, and this is the some middle point is this M. Okay, so let's take here this velocity, how much here, U. Okay, and final velocity how much is given here, V. So we have to calculate with how much velocity this will pass, and remember that here this distance how much here, L by 2. Okay students, so see here please here, first we are going to use the equation of motion. Anyhow it is looking like a third equation of motion. So see here, V square equal to U square plus 2AS. Okay, and first I am going to use between engine and compartment, that means EC. So what we can write as final velocity V square, initial velocity U square. Now the it is passing, no, engine U and backside V. Okay, so remember that here V square equal to U square plus 2A, and how much here distance, L. Okay, so what will happen that here students, here we can write here, see this AL equal to V square minus U square by 2. What is AL? V square minus U square by 2 we have used for engine to compartment. Okay, can you see very well? Now, after that we will use where to where? We will use here engine to midpoint here, mid of the engine here. Okay, so again we'll use here the equations here, the students here, V square equal to U square plus 2AS. Now I will use here this engine to the middle point here. Okay, so middle point what is this? Let's take here V dash square is equal to U square plus 2A. How much length between engine and the middle point? If total length is L, this is how much here, the students here, L by 2. How much here? L by 2. So it will become, yes here the students here, V dash square is equal to U square plus 2 cancel, and what is the value of the AL? Can you see the value of AL? V square minus U square by 2. Okay, so I can put here the value of AL here. Okay, just let me remove this now, and what is coming here, AL is means V square minus U square by 2. Okay, so it is coming here V dash square equal to, take the LCM please, 2, so 2U square plus V square minus U square. So here it will come here V dash is equal to 2U square minus U square means U square, so U square plus V square by 2, and here we will take here the square root. So V dash is coming square root of U square plus V square by 2. Is it? That means which option is correct here? You can see very well here. The correct option is here. Option A is the answer. Is it? So students, I hope so. All these basic questions based upon uniform acceleration, non-uniform acceleration is very clear to you. Keep studying, keep trying.